Good morning. This is Dr. P. Krishnamurthy. Today we are going to discuss about in machine learning, the clustering topic. In the clustering, we have a collection of data objects. So we are going to categorize related and unrelated. So in that, we are finding that two segmentations we are going to use, finding the similarity between the data. According to that characterizations, properties, we are going to group and the similar data object into the cluster. Unsupervised learning, no predefined classes we are specifying. So typical applications we are going to use as a standalone tool, as a pre-processing steps we are going to use to handle our data. So here we are specifying some two clustering things, that is a class 1 and a class 2 we have. So the boundaries we are going to specify. Cluster boundaries we are indicated, that is first one, and then F1 and F2 we are two-dimensional features we are specifying. So here we are indicated like a cluster 1, 2, 3, 4 clusters here, 1, 2, here different ranges we are fixing. So here different ranges we are fixing. So these are all the complex cases of classification and clustering things. So cluster in classification, data points have no label, most data points have label. So here supervised, unsupervised, and here supervised. Identical structure comparisons, here we are specifying structure identify structural properties in data, detects separability among categories, group points based on neighborhood criteria, class assignment, role used to discriminant functions we are having, density or a similar computed we have in discriminant functions and scattered components we are using. Often use priority to classification. Many applications in identification and categorization we are going to use. So some methods we are having a split and representative points, split and merge, linkage, SOM, model-based vector quantizations we are using in cluster, and classification based decision rule, LDA, KNN, feed-forward networks, support vector machine, random forest we are using. So quality, what is here mentioning at good quality clustering method will produce high quality clustering, high interclass similarity, cohesive within cluster, low interclass similarity, and distinct between clusters we have. Quality of clustering methods depends on the similarity measure used by the method, its implementation, and its the ability to discover some or all of the hidden patterns we have. Consideration for cluster analysis, partitioning clustering, separation of clusters, similarity measures, cluster space. So we are having that. So general categorization of cluster data, hierarchical and partitioning. Hierarchical link-based, agglomerative and device. Partitioning, exclusive and probabilistic, MSK, K-mean, K-media, and in probabilistic, GMM, FCM we are using. Alternative view of algorithms for clustering. Unsupervised learning or classifications, here we are having K-means or K-media. So we are having density estimation, parametric we are using Gaussian, mixture of Gaussian, uh, direct beta, branch and bound process, piecewise quadratic boundary, nearest mean classifier, maximum likelihood estimations we have. Density, here we are estimation, non-parametric histogram, neighborhood, kernel method, graph theory, iterative value seeking are we are using. So an example of k-mean clusters we are using here, and in fuzzy C-mean clustering. So this method has objective functions to be minimized. Here we are specifying Jm, here we indicate summation of I is equal to 1 to n, j is equal to 1 to c. So here summation of the I and j value we are using u, that is objective value we are taken up u to I and j value to maximum m, mod and mod of square value xi minus ju mu value whole square. So that value between the range 1 less than or equal to infinite, that is m value. So mu m u I and j is the degree of membership of xi xj in the cluster j. Xi is a d-dimensional observation. Mu I j is a dimensional center of the cluster. So here, Fuzzy means iterative optimization approach. Here we are using At each step, the membership U, I and J and the cluster handlers, we are using mu J are updated as follows. 1 by U, I and J equal to 1 summation of K equal to 1 to C mod of X I minus mu J mod divided by mod X I minus mu K whole square into m minus 1. So similarly, mu j is equal to summation of I equal to 1 to n mu u I and j power of m value into x I day divided by summation of I equal to 1 to n m into u I and j value will be updated. We are using that termination criterion. We are going to use it. Here we are indicated k means and posi c means. So some deviations here we are going to use it. The media will be we are specified. So this is the original data. The centroid value here we are specified. So that value will be second principal component and first principal component we are will be analyzed. So this is the original data space. So this value will be scattered, and here we are finding that PCA1 and PCA2 value, the PCA1 and PCA2 value will be segregated. So in this way. So the next one is hierarchical clustering, building hierarchy of cluster, bottom up and top down approach. The top down approach is a device, a bottom up approach is agglomerative clustering. So then distance based functions we are using. So find out that distance measures or metric. Distance of x and y greater than or equal to 0 for all x and y is the region. So d of x y equal to distance of x and y is equal to 0 if f of x equal to x equal to y. So distance of x comma y is equal to d of x comma d of y comma x is symmetric, that is irreversible. So if d of x comma y is less than or equal to d of x comma z, and then iterative value will be the next region value will be we are going to take it now. So equivalent distance formula we are going to use d of x comma y is equal to some root of summation of I is equal to 1 to d mod of x minus I whole square. So the probability the most commonly used in this matrix, here we are following that. Some commonly used metrics we are having equivalent distance, squared equivalent distance, Manhattan is distance, maximum distance, Mahalanobis distance. So these are the distance metrics we are using to find out that. Agglomerative clusterings we are using each node or object is a cluster. Initially we are having that merge cluster that have a the least dissimilarity, and then go on in a non-descending fashion. Eventually all nodes being belong to the same clusters we are having it. Here single linkage, complex linkage clusters we have it. So specifications we have it. Device clustering, all data in the same cluster, the largest cluster split until every object is separable we are going to use. What are the true number of clusters we have? So this is a hierarchical structure. So the similarity we are going to find out that clustering data object is obtained by cutting the dendrogram at the desired level. We are going to connect each level. So density based and spatial clustering of application within noise. So we are using that major various features we have: handle noise, need density parameters, termination conditions, arbitrary shapes we are going to use. So DB scan, optics, DenClue, ClickQ. So we are using these are all the algorithms various authors are introduced in 96, 99, 98, 98 respectively. Reachable, density based reachable, and density based connected objects also here we are mentioning it. So the algorithm is given here. Nonlinear separable clusters we have in DBScan. So this classification and clustering differentiation is discussed now. The session will be ended now. Thank you.